Eventually, I'm sure the good weather will continue. We're in this beautiful, dry, settled spell, aren't we? Where it's just a bit sort of cool and it's just lovely. I don't mind winters like this. We haven't had one named storm yet this winter, 22-23.
Because it was February last year we had Eunice, wasn't it? Eunice caused all sorts of damage.
The tree came down in the triangle in Bude. The roof went off of the lifeboat station. No, my goodness me. No, so we haven't had a single storm like that this season, which is quite...
Let's not speak too soon.
Well, there's still time. There's still time.
Because there is speculation about this beast from the east returning, isn't there?
Yeah, but that will slow it down. If it remains cold, it will be calm and settled, which is fine. I think I can deal with the cold. I'm not quite sure about the wet and windy weather. My porch still leaks, so really need to sort that out, really. Look, we are talking sort of loosely related to the different weather conditions we're having and the climate in general, because Cornwall is to host an international team of scientists who are working out if they have a potential solution to one of the most pressing issues facing the planet, which is climate change. And this is a Canadian company who want to come here to Cornwall, do some studies and collaborate. And I mean, it'll take some explaining, so you'll have to bear with me, but you can hear that after 10 o'clock. It's a bit of a exclusive chat that we've got for you about these Canadian scientists that have funding and they want to come over here and see how we do things and collaborate, and it's all very interesting. So we'll see how we go with that. Also on the programme, Cornwall set to host an international team of scientists who are trying to work out if they've got a potential solution to climate change. This is a Canadian project that aims to remove carbon from the atmosphere right here in Cornwall.
There is trouble, we'll stop. But if we don't do something, the climate is going to continue to degrade, and the environment around Cornwall will continue to degrade as well. The ocean is just too acidic. And so we have a problem. Let's start addressing it.
It's a really interesting scheme, and you'll hear all about it in about half an hour from now. Now, this story sounds like science fiction, but actually it's science fact. Cornwall is to host an international team of scientists working out if they have the potential solution to one of the most pressing issues facing the planet. It's a Canadian company called Planetary that aims to remove carbon from the atmosphere and at the same time reduce the dangerous acidification of the ocean by adding mild alkaline substances to the sea. So we're changing the sea, and then it will change the atmosphere. And this is a limited trial that was carried out back in September, and a 3 to 4 month major experiment is now planned for Cornwall later this year. So the world's going to be looking to us as we do these studies, because it could really be life-changing and ease some of the worries from climate scientists. What are, though, the implications of going in and adding things into the sea to try and change the atmosphere? Are there any risks from this? Community events are planned from early March to answer some of these questions of the scheme, and they've already got the go-ahead of the Curve to talk to Truro-based climate consultant Luci Isaacson. And also we've got Pete Chargin from Planetary. And they joined Julie from San Francisco to talk more about the project.
Planetary is leading in a technology that's called Ocean Alkalinity Enhancement. And it has 2 basic goals. The first is to restore the climate, and the second is to restore the ocean, because the ocean has become, over the last few years, very acidic. The process is very simple. It simply accelerates the natural carbon cycle that's been in existence for millions of years. Since the ocean is acidic, what's the best way to counter that? With an antacid. So what we do is we take, sometimes we call it alkalinity, but we take an antacid and we add that to the ocean. When we add that to the ocean, it reacts with the acidity that is in the ocean, and it changes the dissolved carbon dioxide that's in the ocean into a salt. And as you know, salt is very prevalent already in the ocean. Because then the CO2 that is dissolved in the ocean has been depleted and changed into a salt, the CO2 that's in the air then migrates into the ocean, and we've removed a little bit of carbon dioxide and we've removed a little bit of acidity and changed it into salt. That's how it works.
So that's the chemistry of it. Just describe this alkaline substance that you put into the ocean. I imagine it isn't a great big pack of indigestion pills. What is it? Where does it come from?
Well, actually, it's the exact same thing chemically as an indigestion pill or milk of magnesia, which people use also for upset stomachs. It comes from many different places around the world. The best place that it will come from is a process that Planetary has invented. What we do is we take mine tailings, which are available pretty much all around the world. We purify those mine tailings, so we remove anything that might be toxic or harmful in any way. And then we get out of that this substance, this alkalinity at the very end. The specific substance that we use for anyone who's sort of chemistry inclined is called magnesium hydroxide, and that is exactly what you find in milk of magnesia.
What scale of operation will people see? Because you've already carried out a smaller scale trial in Cornwall in September. This is going to be a major trial, and we'll talk about the funding of that in a minute. But what scale of operation are we going to see? Lorries taking this purified mine waste and putting it into the sea? Will there be a pipeline? What will people see in the way of infrastructure?
People probably won't see anything. This is a very important trial, but it's relatively short. It's only 90 days or perhaps 120 days. So it's not a very long trial. There's not going to be new train loads of milk of magnesia coming into any of the local ports or anything like that. What we will do is we will add a few tons of this, probably a couple of hundred tons over a period of 90 days into what we call an outfall, an ocean outfall. And that ocean outfall that we're using is through a wastewater pipe. And we will add this starting at the wastewater treatment plant, and then it goes out to the ocean. When it gets to the ocean, it mixes very quickly. As everyone here knows, the ocean is not calm. It's always churning. And that's a good thing from this point of view, because then it mixes up right away. It turns into this salt right away. You aren't going to be able to tell that anything has happened unless you're out there with a very expensive scientific measurement device trying to check the ocean chemistry, and that's exactly what we're going to do.
People are very nervous about any change to our natural environment because, let's face it, humans have got previous by trying to do good and ending up with another problem than the one they were trying to solve, like the introduction of rabbits into Australia, for example, or cane toads. So people will be perhaps very twitchy about us really knowing the repercussions of what we're going to do. Have you looked into what this could do to marine wildlife, to the ecosystems around this outfall, and the impact, say, for example, on fishing?
The answer to that is I'm very glad that people are cautious. I call it bring on your questions, bring on your cautious approach. We feel exactly the same way. There have been many scientific studies all around the world. Many of them are based in the lab, and that's one thing. Some of them are based in the ocean. For example, there's been a few studies in Australia where they add a little bit of this alkalinity into the ocean. It has actually improved the local environment. However, no testing has been done in Cornwall. And so we will start with a small trial, this 90-day trial, where we are adding 0.016% of the effluent, right? So we're just adding really a drop in the ocean into the local environment. And we will measure it. We will look at the environment beforehand. We will measure it as it's being added to the ocean, as this climate mitigation is happening. And then we will look afterwards to make sure that no harm has been done. If there is any sign of trouble, we'll stop. We will just stop. We don't expect to see any trouble because we have done quite a bit of lab work and other work around the world. If there is trouble, we'll stop. But if we don't do something, the climate is going to continue to degrade, and the environment around Cornwall will continue to degrade as well. The ocean is just too acidic. And so we have a problem. Let's start addressing it.
The company's based in Canada. You're based in San Francisco. Cornwall is, well, we're very proud of Cornwall, but it is quite a remote little corner of the world. Why here?
I love Cornwall. Actually, I grew up in a town in California called Grass Valley.
Yes. Well, you know all the Cousin Jacks and Cousin Jennies from the migration from Cornwall, yeah.
Exactly. I grew up eating pasties. So around here they call them pasties. Anyway, why Cornwall? It's a great place for this ocean alkalinity enhancement. St. Ives Bay, in addition to being beautiful, is, as I mentioned, very turbulent. It mixes up very quickly, and that's a good thing from a local safety point of view. It also turns out that it's relatively shallow. And because it's shallow, then we are convinced, based on a bunch of modeling work that we have done in the local area, that there won't be any change to the local environment because it gets dispersed so quickly. And then the third thing is the currents around Cornwall take this little bit of ocean alkalinity enhancement that we've done, and it runs that directly up the coast, over the top of Scotland and down into the North Sea. And so that's also generally a very shallow area, which is good, again, for this mixing. So it turns out Cornwall and lots of places, especially up the west coast of the UK, are perfect for this type of climate mitigation.
We also have, of course, quite a considerable, admittedly slightly dormant mining industry. Will you be getting the mine waste that you're going to purify locally as well?
So we have not yet done any mine waste evaluation for Cornwall. It's possible that we will do it, but we wanted to start with the ocean part first, and check that science. Spinning up a mining organization or working with mine tailings, you're working with millions of tons at a time. We wanted to start smaller, and so we're starting with the ocean piece.
You're hearing there Pete Chargin from Planetary, who joined Julie live from San Francisco. A bit later on as well, we're going to be talking to Truro-based climate consultant Luci Isaacson, who will have some thoughts on this scheme, which sounds, well, like something I never even imagined would be possible. More about that climate change potential solution here in Cornwall. That's coming up after 11. We spoke about this in the last half hour, and we're going to bring you a bit more on this story now, because this could be a big thing for Cornwall. Gosh, it feels like there's a lot going on down here at the minute with the spaceport and lithium bits and pieces bubbling away, and then we've got this. A team of international scientists are working out if we've got the potential solution to climate change and problems surrounding it, and they're coming to Cornwall to do some experiments in this field. So this is a Canadian company called Planetary that aims to remove carbon from the atmosphere and at the same time reduce the dangerous acidification of the ocean by adding mild alkaline substances to our sea. And they've already done a limited trial that was carried out back in September, a 3 to 4 month experiment. And now they're looking at doing a bigger experiment here in Cornwall later this year. So what are the implications of this? Are there any risks from it? There are going to be several community events planned for early March to answer questions on the scheme, but we just wanted to get an overview because this is a new story to me. I don't know about you. We spoke to Truro-based climate consultant Luci Isaacson, and also you'll hear here Pete Chargin talking, he's from Planetary, talking about this. So here's the second part of the chat that Jules recorded earlier.
Let's talk about the scale of this project and the ambition. I believe that this was funded, wasn't it, by the Elon Musk Foundation's climate grants. They're quite few and far between. So how is this experiment being viewed on a global scale in the science community?
So for us to have a real impact on the climate and on the environment around the world, we need to scale this and many other climate solutions to very large scale. The phrase that people use is it's a gigaton problem. And that a gigaton is 1 billion tons of carbon dioxide. And we need, according to the UN, we need to remove about 10 billion tons of carbon dioxide from the atmosphere every year. Now, that's not until 2050, and so we have to build up there. Right now, the industry of carbon removal is, in the hundreds of thousands of tons. So we have a long way to go. This is a worldwide problem. So the figures I'm about to give you don't apply just to Cornwall. But around the world, it's billions of tons that we need to remove. Now, regarding funding, there are lots of different places that funding comes from. It comes from government grants in the UK. Actually, we started with a little bit of modeling work that I referred to. That was funded in part by a UK government grant. There are government grants in Canada, and there are government grants in the US and around the world, because governments are coming to realize that we need to solve this problem, and it's going to take capital to do that and to make sure that the science plays out in the real world. There are venture capitalists who might fund this. There are companies who we call catalytic investors, catalytic capital, who want to see this improvement in the environment, and so they are taking their hard-earned profits and asking us to do it. So, for example, a company called Shopify is one of Planetary's early carbon purchasers, and they do that on a catalytic basis. They're paying much more than anyone else would pay in order to help us do that. And they are actually the source of funding for this specific new trial in Cornwall. We were awarded an Elon Musk prize, a carbon removal prize from the X Prize Foundation. That was $1 million, and so we were the winner there. That was called a milestone award, and that was last year.
What would be the criteria to judge this next trial that will be launched a success?
Two main criteria that we're looking at to judge this a success. The first is a positive one, and the second one is the absence of a negative one. So the positive outcome that we're looking for is that we are able to measure the carbon dioxide removal. And we can do that in a couple of ways with these very fancy sensors that we're happy to show people. So we are trying to measure the carbon removal and the acidity change. Sometimes that acidity is called pH. The other thing is the absence of a negative. We want to make sure that there is no negative impact to any of the local area. And we will do that through, we'll be measuring what's the health of the water column in terms of phytoplankton. So we'll be looking at it at a microscopic level. We'll look at the chemistry of the ocean, also clearly at a microscopic level. And we'll look at it at a, kind of visually. Is there any impact at all to any living organisms that we can see either in the sediment around where the outfall is or anything nearby? We really don't believe there's going to be any change, but let's make sure.
Thank you so much for talking to me, Pete. I'm going to bring in Luci now, Luci Isaacson, who is a climate consultant with the company Climate Vision based here in Truro. What do you make of this? You are a fully fledged climate investigator and somebody with concerns for the environment. When you first heard this, do you think it sounded like science fiction?
A little. I was a little bit concerned at first, as anybody would be. But as I started to explore what the project was going to be and spending a lot of time with the Planetary team members and understanding more about their backgrounds and their plans, it's been really rewarding, Julie. It's been even a humbling experience, because I have to admit, I have a reputation for being optimistic about the climate. That was starting to wane a little towards the end of last year. And, now I think we've got a real great opportunity, and it's going to be really exciting to share that with people of Cornwall.
As I said to Pete, people have a totally understandable anxiousness about anybody trying to manipulate our environment. What do you consider to be the reaction that's likely to come forward in Cornwall now this project has gone public?
I think most people will want to know how we're going to protect biodiversity, marine biodiversity, and why do we need to do this? And I think people will be concerned a little bit about climate change and not really having a full handle on it. So I think we're going to have a couple of events where we're going to invite people to come along and hear more about it, and so that they can ask those questions. But one of the things I've done over the last 4 weeks is really bury my head in the new science that's been coming out, and journals that have been published even in December just gone, peer-reviewed science. And for people that don't know what that means, independent other people look at people's research that's been published. It won't be published until everyone agrees on it. And a lot of that and those studies deem this procedure as totally justifiable in relation to what it can do to help the climate and to address ocean acidification. So I think that'll be the first one. And I have a stack of journals that are saying we need more research, we need to do this, we need to test it. And then on the other hand, I think a lot of people will also maybe query, why Cornwall? And that's one of the things that I find quite exciting. So as Pete said, we need to remove, the IPCC have said we need to remove 5 to 16 gigatons annually from the atmosphere of emissions. And for people that don't know what that means, I actually looked it up earlier. 1 gigaton, you can imagine, is roughly 200 million elephants. Okay.
Yes, I can't imagine 200 million elephants, but then maybe that's just I've got a lack of imagination.
But it's just important to see how big it really, really is, and that we have that possibility to do it.
We know that Cornwall is very much trying to reposition itself right now into a place at the forefront of technology and science. We've got the spaceport, we've got the search for lithium. Where do you, Lucy, as somebody in Cornwall, feel that this fits with that vision for high-tech Cornwall?
I think it's really important that we can see that this is going to really help trailblaze the green industrial revolution. I think this is a really important time to share this knowledge and also the opportunities. And, there's risks with any climate intervention, but this Ocean Alkalinity Enhancement is a great opportunity to really put Cornwall on the map. I think the important part about it is to understand it, you need to understand a little bit about climate science. And Mike Kelland, the Planetary Chief Executive Officer, has an ambition to restore the climate by pulling a gigaton of carbon out of the atmosphere by 2035. And that's a fifth of what the IPCC is saying. So here we are, Cornwall, testing solutions globally, hopefully right here. And, it's 220 years ago this year that Richard Trevithick constructed the first steam railway locomotive, kickstarting the Industrial Revolution. I say, let's go, let's do this and be excited about it.
Well, sounds like quite the scheme. You heard their Truro-based climate consultant, Luci Isaacson, and also the other voice on that was Pete Chargin from Planetary. That chat with Jules recorded late yesterday because obviously Pete is over abroad working on this at the minute in Canada. The Canadian company is called Planetary, and they aim to remove carbon from the atmosphere and at the same time reduce the dangerous acidification of the ocean. And what they'll do is they'll add in sort of different, it's like recipe book really, add in mild alkaline substances to the sea until the balance is just there, and then hopefully it makes a difference to the sea and the atmosphere around us. Does it sound interesting to you? There's going to be, the experiments will probably happen in Cornwall later this year, but so we know the implications and risks and what it's all going to be about, the community events are planned for early March to answer questions on the scheme. You can find out more if you want to go along. I mean, there's an event on the 2nd of March in Truro that you can go to. If you want to find out a little bit more, you can actually follow Luci Isaacson on Twitter if you search for Climate Vision UK, and she has all the details on there.
BBC Radio Cornwall. Cornwall Cornwall is to trial a potentially groundbreaking technology that could help reduce carbon in the air whilst also reducing the acidity of the ocean. It's the idea of a Canadian company called Planetary, which has investment from Elon Musk. It will do its ocean experiments in Hayle this spring. Luci Isaacson is a climate consultant based in Truro.
This is going to really help trailblaze the green industrial revolution. I think this is a really important time to share this knowledge and also the opportunities. And, there's risks with any climate intervention, but this Ocean Alkalinity Enhancement is a great opportunity to really put Cornwall on the map.
Cornwall will trial a potentially game-changing technology that aims to pull carbon out of the air and reduce ocean acidification. Canadian company Planetary will trial the new technology in Hayle this spring. The Vice President of Planetary is Pete Chargin, and he explains how it will work.
We take an antacid and we add that to the ocean. When we add that to the ocean, it reacts with the acidity that is in the ocean, and it changes the dissolved carbon dioxide that's in the ocean into a salt. And as you know, salt is very prevalent already in the ocean.